Okay, so we have our question here for tonight's tutoring. So this is concerning finding the difference between vertical asymptotes, horizontal asymptotes. How do we find them in um, using the Rady method, and what do they mean? So we'll start with the vertical asymptote. So I have this function that I made up here. So this has already been factored for us. So again, I would reference, if you want to look at further examples, the notes that I posted up on Google Classroom. Please make sure, look at the stuff, look at the videos that I've posted up already with regards to the actual class recordings. So then that way you can reference those, because we've done multiple examples, so that way you can kind of see. But again, I'm just going to give a quick summary of this. So please do not just only reference this video. I'm letting you know just so guys can kind of go back and look at the other previous videos as well. So to find the vertical asymptotes in a rational function, we focus on the denominator of the function, and we check when or what values of x are going to make that denominator equal to 0. So in this case that we have here, since this has already been factored for us, it makes it very easy for us to determine that. That's going to happen at x equals -3, and then again at x equals 4. This would be the location of my vertical asymptotes. So in this case, I'm going to end up having 2 vertical asymptotes. Graphically, what does that mean for us? Well, graphically, that would mean, as I make my sketch, those are going to be 2 places vertically that my graph cannot cross or touch. So I would put it here at -3, and then another one over here at +4. So that's what that means. Vertical, up and down line, asymptote, barrier that we are not going to cross. Now moving into a horizontal asymptote, now to find this, we need to compare the degrees of the numerator and the denominator and compare. So when it's factored, this makes it a little bit harder to do. So the numerator, again, I look at those lead terms. So here, this is x times x squared. So that means the degree in the numerator would be x cubed. Down in the denominator, I have an x cubed times an x squared. So that would make that x to the 5th. So hopefully you remember how to multiply exponentials. So that means we would add the powers. So x to the 3rd times x squared. That would give me x to the 5th. The powers add. Okay, same thing up here. X times x squared would be x to the 3rd. So remember the test. If the degrees are the same, I would have divided the lead coefficients. Obviously, they are not the same. If the degree in the numerator is less than the degree in the denominator, then that automatically makes my horizontal asymptote 0. So this would be my horizontal asymptote. And if it were the other way around, if it were the higher power in the numerator and the lower power in the denominator, then I have no horizontal asymptote. So there's a difference between when the horizontal asymptote is 0 and that there is no horizontal asymptote. So on my graph, again, I would be showing right on the x-axis is that horizontal asymptote of 0. Okay, so that's what that signifies on my graph. So again, make sure, go back, look at our previous class videos where we did examples. Look at the notes that I've posted up on the Google Classroom. Look at the Rady method. Inside the Rady method itself, it gives you this same test that we did here with the degrees on being able to determine which is which. So again, this one video is not made to kind of circumvent all that other previous material. Please make sure to go back and review everything that we have done on up to this point. Okay, so that just to kind of clarify the difference between a vertical asymptote and a horizontal asymptote and how we would determine the two.